Hello all. This is the fifth module of your syllabus. So in this session we will see introduction to this transaction processing. So this is the outline of this lecture. We will see what are transactions, then what is the data model that we will be using, then why concurrency control is needed, and why recovery is needed. So transaction. So if you take a system, all the systems have many transaction. We can consider everything as transaction processing systems. So transaction, it provides a mechanism for describing local unit of data processing. So transaction processing systems are systems with large databases, and there will be hundreds of concurrent users executing this database transactions. For example, airline reservation systems, banking system, or the stock markets, supermarkets. All these are transaction processing systems. So the basic need is they require high availability and fast response time is needed. So we'll see what is transaction and all. Before going into that, we have already studied there are two types of when we consider database systems. We have single user and multi-user systems. Database systems can be single user DBMS and multi-user DBMS is there. In single user DBMS, at most one user will be using the system at a time, and in multi-user systems, more than one users can use the system. So the database will be accessed concurrently. In single user system, only one person will be using, but in multi-user DBMS, more than one user will be using the system. Okay. So most of the DBMS are multi-user systems. If you take airline reservation, there will be thousands of people who will be reserving a ticket at a time. Or banking system, thousands of users, cashiers, bank managers. All these people will be using the same software. They will be accessing the same database. Okay. So, how this multi-user systems allow this transaction processing is the concept of multi-programming will come. You have already studied in operating system about multi-programming. That is, a computer can execute multiple programs or processes at the same time. So that is known as multi-programming. A computer can execute multiple programs or processes at the same time in a single CPU itself. We have only a single CPU, and that CPU can execute more than one processor at a time. That is known as multi-programming. So this is how multi-programming does. So if a process A is there, after some time it will be suspended, and next another process or B program will be running. Then after that, A will be running. Then it will be suspended again. After that, B will be running. So this is time. So at T1, A will be executing, and at another time, B will start its execution. So it is running in a single CPU. Multiple processes will be running in a single single CPU. So they execute in interleaved manner. We call it as interleaving. Okay. But if we have more than one CPU, we can execute parallelly. So this is parallel processing, and this is interleaved concurrency. So we'll be discussing mainly about this multi-programming system. Okay, we have only a single CPU, and there will be multiple users accessing the same database. So this is similar to the multi-user database. So multiple transactions will be accessing the same system. Okay. Transactions. So we'll see what is a transaction. So transaction, it is an executing program, and it forms the logical unit of database processing. A transaction, it is an executing program, and it is a logical unit of database processing. It includes one or more database operations, database accesses, or database operations like which includes insertion, deletion, modification, or retrieval operations. All these operations will be considered as transaction. So a transaction may not be a single insertion. It may be a combination of insertion plus deletion or insertion plus modification, modification plus retrieval. Everything will be combined and it forms a single unit. Then it is known as transaction. Okay. So it is an executing program. As transaction does not mean that it's a single insertion or a single deletion. It may be a combination of several such operations. Okay. So you should understand what is a transaction. So it is a combination of all these operations. Maybe even a single retrieval operation will consist of several operations inside that retrieval. Okay. So every transaction will consider there is a boundary for transaction. We specify using a begin and end transaction statement. So there will be a begin and end statement. So for a transaction, there will be a begin and there will be an end. So between this begin and end, there will be multiple operations inside that. Okay. So maybe an insertion plus a deletion. So it will form a transaction, a single transaction. So this specifies the transaction boundaries. Then there will be a read-only transaction. If we have only retrieval operations, then we call it as read-only transaction. Then there will be we can have read-write transactions. So all other transactions will be considered as read-write transactions. So if we retrieve only data, then it is known as read-only transaction. And if all other transactions are known as read-write transaction. Then we'll see the database model that is used to present this transaction processing. So database represented will be represented as a collection of named data items. The size of the data item we call it as granularity, or it is the size of the data item. It can be anything. It can be a data item, can be a database record, or it can be a disk block that is to be brought to the memory, or even a simple attribute value of a record. All these will be considered as data items. So transaction processing concepts independent of this item guarantee. We don't consider what this database item guarantee when we consider this transaction processing. All these will be considered as items. Okay. Then read and write operations in transaction. So in order to understand this transaction processing, we'll have a model for this transaction or database. So we call it as read item of X. So this is known as read operation, read item of X. So in read item of X, what it does is it reads a database item named X into a program variable named X. So this is the meaning of this read item of X. Then this can include many other inner things. Maybe it will have to find the address of the disk block that contains that item X, then copy that disk block into a buffer in main memory, then then copy that item from buffer to the program variable X. Like that, there will be several different steps in this read item of X. So if we say read item of X, it includes many other steps. So like you have to find which address block we have to bring, then we have to copy it to memory buffer, and then we have to write it into the actual variable X. Similarly, write item of X. So write item of X means writes a value of program variable X into the database item X. This means we are writing something. So it should be copied into the disk block. So it will include finding the address of the actual disk block, copying to and from the memory buffer, and storing it in the updated disk block back to the disk. So we have to write it into the disk. So all this will be considered as write item of X. Okay. So these are some of the concepts that we should understand in order to say about transaction processing. So this is an example of transaction. This is an example of transaction. We call it as transaction one, T1, and we have read item of X. Here read item of X is there. Then what we do is inside the transaction we are decrementing its value X minus N. Then we are performing write item of X. So it will be copied to the disk. Okay, whatever we have made changes, that should be made into the disk also. Then again we are reading another item Y, and we are incrementing that Y plus N, and we are writing it back to the hard disk. Okay, and this is another transaction. We have read item of X, and we are incrementing it by X plus M. Then we are writing it back to the X hard disk. So if we say read set of a transaction means the set of items that the transaction reads. So it is X and Y in T1. So we are reading X and also we are reading Y for transaction 1. Then write set of transaction means whatever items, a set of all items written. So if we take this transaction, X and Y are written. So here we are writing only X item. So, write item of X is write item of T2 is X alone. Okay. And read item of T2 is X alone. Okay. So if we consider this as an airline reservation system, it may be some number of seats that will be decremented, and some other flight, some other people will be canceling. So some other uh, flights, number of seats will be added. Like that, we can consider. Or if it is a bank, some amount will be deducted, and this will be some amount will be credited. Okay, such this may be considered as some X account, or this may be considered as a Y account. So into this some amount is put like that. So why concurrency is needed? So if we execute these two transactions concurrently, so T1 and T2 are two transactions, and if we execute these two transactions concurrently in an uncontrolled manner, then there will be some problems that can occur in our database. So if we are trying to execute this concurrently, then this will be working in interleaved manner. For example, okay, now we will see that. So what happens is this T1 won't be executed completely. In between T2, some operations will be executed. For example, after reading read item X, then after doing this X equal to X minus N, then T2, after that, it is executing in interleaved manner. So then after that, if T2 reads the item X, it will be reading the old X rather than this X, because this write operation is not performed. So when this write operation is performed only, it will be copied to the hard disk. So when it tries to read, it will be reading the old value of X. So if we are executing in interleaved manner, there will be some problems that can occur with this thing. Okay. So transactions submitted by various users may execute concurrently. So access and update, they will be accessing and updating the same database items. So that may be a problem. For example, a person is withdrawing some amount from an account, and some other person is adding some money to that account. So what happens is, if the person who is withdrawing that amount is not getting the updated amount, then there will be some problem, and he may lose some money, or some money may get added to his account also. So if concurrently they are executing, there may be several problems that might happen if they are executing in an interleaved fashion. Okay. So some form of concurrency is needed here. So there are several problems that occur in this concurrency, in this when we do this transaction processing, and if we are not controlling this concurrency, there are several problems that can occur. One is lost update problem. Then we have second problem, we call it as temporary update or dirty read problem, and third is incorrect summary problem, and fourth is unrepeatable read problem. So we will see all these four problems in this session. So first one is lost update problem. So this occurs when two transactions that access the same database items have operations interleaved. Okay, so it results in incorrect values of some database items. For example, so we have already seen T1 and T2. So if they are executing in this interleaved manner, then there is a problem. There can problem can occur in this interleaved operation. So what happens is here T1 is reading an item X, and now T1 is updating X equal to X minus 1. So this is a type chart. Then after that, since it is executing concurrently, then there is a possibility that T2 will be reading the item X. So what happens here is T2 will not be reading this updated X value because it will read from the hard disk. So what it have in the hard disk is the old value of X. For example, if we have X as 100 initially, here X minus 50 is done. But when so here X becomes 50. But when T2 reads this X, it will be old 50 itself. Then X is updated here. So X becomes, we will be adding some 10. So X becomes 10. Then after that, we are writing this X. So what happens is, what will be the value means the X will be writing 110. Okay, 110. Then we are reading this read item of X. Then after that, again write item of X is performed. Again 110 will be written. So this update is lost. So this update is lost when we perform like this. So this is known as lost update problem. So lost update. So we are losing this update because, so here item X has incorrect value because its update by T1 is lost. So this update is lost. Okay, so this is known as lost update problem. We are overwriting it. So what happens is if X was 50 initially, sorry, X was 100 and we have decremented it to 50. And after that, when we read here, again it is 100 which is being read. Then we are updating the value of X. It will become 110. Then what happens is when we perform this write item of X, it is 110 that is written. Then after that, again when write item of X is done, again 110 will be overwritten. So what happens is X minus n, then 50 is lost there. So this update is lost. So this is known as lost update problem. So this can occur in transaction processing. So that is why we require this concurrency control mechanism. Then the second type of problem, we call it as temporary update or dirty read problem. So this problem occurs when one transaction updates a database item and then the transaction fails for some reason. Okay, and that transaction fails for some reason. So then that is known as a lost update problem. For example, T1 and T2, the same transaction, we are reading this item X, then we are subtracting this X minus n, then we are writing this X. So that is okay. Then after that we are reading. So if we have initial value was X, then X minus 100 minus 50 is done and 50 will be written. After that, this read item of X is read. So we will get the updated value, that is 50. Then we are performing 50 plus 10, it becomes 60. Then we are writing it back. So 60 will be written back. Then after that, at this point of time, if transaction T1 fails, if this transaction T1 fails, and must change the value of X back to its old value, because this transaction has failed because it has not been completely done. So if a transaction has started, if it is not completely done, then all the updations it has made, it has to be made back to the old problem. So T1 has failed. So what happens is T2 has already read the temporary value of X and it has made some updations and it has been written. So the problem is this is known as dirty read. Dirty read. This is actually a temporary update that was made here in transaction T1 and that was read by this T2. So this is known as dirty read. So it should not be read actually at that time because T1 has been failed. T1 transaction has failed and it has been aborted. Aborted means all these operations should be reverted back. Okay. But T2 in between has has taken that updated value and performed some operations. So there is a problem with this. So this is known as temporary update or dirty read problem. So what happens is this is reading, this T2 is reading the temporary update that has been made, and it will be updating it and it will be writing back to the disk. And if T1 fails, all these transactions should be made to the old value. So everything is a problem there. Okay. So this is known as temporary update or dirty read problem. Then the third type of problem can occur is known as incorrect summary problem. If we have the same transaction and if we have another transaction T3, this is another transaction T3, and what it does is it will simply sum up all the items that are being read. Okay, so here some other items as read item A has been done, and some become sum plus A. Like this, it is summarizing what all items that are being read. Then here transaction T1 has been read here. So read item of X is performed, X equal to X minus N is done, then write item of X is done. So this read item should be updated in the summary also. So that is being updated here. Sum plus X has been done. Then we are reading another item Y, then sum plus Y is done like that. Now T3 reads X after N is subtracted here and read Y before n is added. So this is there's a wrong summary problem because read item of X, after performing this read item, immediately this should be added, that one item has been added. So what happens is because of interleaved fashion, after subtracting only this is being updated. Actually we have done two updations here, two updations. So if X was 50, 100 here, and X has become 50, and what it reads is it will be reading 50. Actually it should have read 100 first, then that sum should be added here, then after that only this read item of Y should be performed. So this is known as incorrect summary. So incorrect summary means if there is a transaction that is summing up all these read items, then there is a problem with that summary. That summary is out. It is not actually the actual summary. So if for example if it is a airline reservation system and this is the number of seats that are being subtracted and added, then the total number of seats that will be available will be different from this, the actual thing. So T3 reads X after N is subtracted, so it should have been read before that. Okay, so that is a problem. So this is known as incorrect summary problem. Then the fourth problem is unrepeatable read problem. So here this occurs when a transaction T reads the same item twice, and value of that item is changed by another transaction T dash between these two reads. So we have a transaction and that transaction reads the same item twice. That is read item of X and read item of X. Two operations are there. But in between, another transaction T dash has changed the value of T. But the problem is it will be reading the same item twice. So it is known as unrepeatable read problem. So there will be a different value at two reads. Okay, first read it will be reading 100, and in between if some other transaction has changed its value, then this read again if it reads it will be 75. So it is known as unrepeatable read problem. Okay. So T receives different values for the two reads of the same item. So for all these reasons, for all these four reasons, we require concurrency control. If we have properly controlled that concurrency, then these problems wouldn't have occurred. Then why recovery is needed? So, so before going into this recovery, we have to understand what you mean by this committed transaction. Committed transaction. So a committed transaction means all the effects have been recorded permanently in the database. Then it is known as a committed transaction. So after completing a transaction, there will be a commit operation at the end. Commit operation means everything has been should be written into the disk. so it will be stored permanently. Okay. Then there is we have another transaction which is aborted transaction. It means it does not affect the database. That means if we abort a transaction, all the updates we have been made should be made into the original value, because we are aborting the transaction. So if we have made some values in x and y, all those should be made into the previous value, and we will abort that transaction. Okay. So there is commit transaction means it is permanently, then there is no problem. But abort a transaction, if some failure occurs, we have to abort the transaction. So what all changes we have made, we should go back to the previous state. So there we require this recovery. So recovery, there can be several transaction failures. So we'll see what are the different types of failures that can occur in a transaction system. Okay. So first one is computer failure or system crash. It may be a hardware, a software, or network or errors can occur in the computer system during transaction processing. So hardware crashes may be main memory failure, RAM failure, all these can occur. So in those cases, we have to abort the transaction and we have to revert back to the original values. Then another is transaction or system failure can occur. So maybe some operation in the transaction may fail. For example, division by zero or integer overflow. These can occur in a problem. Or some error values in parameters. All these are known as logical programming error. So this can be a problem to the transaction. So that transaction should be aborted. Then local errors or exception conditions detected by the transaction. This is another kind of failure. So during transaction processing, there may be several conditions that occur for which the transaction should be cancelled. For example, data for that transaction may not be found. For example, if we try to withdraw some amount from the account, and if sufficient balance is not there in the account, then that is known as local error or exception conditions. If that amount is not there, that person should not be allowed to withdraw that amount. Then that transaction should be aborted. Okay. So this is known as local errors or exception errors. Then we have another failure, we call it as concurrency control enforcement. So when we strictly enforce this concurrency control, then may have to abort some transactions which violates its serializability. We will be learning about this concurrency control enforcement later. Then you will understand what is there. So, in order to ensure that serializability, if it violates serializability, we will be aborting some transactions. So, what we have to do is we have to restore the previous values. So, that is known as recovery. Then disk failures can occur. So maybe some disk blocks may lose their data item during a read write malfunction, or a hard disk may crash. All these things can happen. So we have to recover from this disk failure. Then another type of failure is physical problems or catastrophes. So this is actually it can be air conditioning failure, theft, overwriting disk by mistake. All these will come under this physical problems or catastrophes. So failures 1, 2, 3, and 4. So this 1, 2, 3, and 4. This concurrency control enforcement. All the first four failures are common, and type 5 and 6 are uncommon. There will be several different ways to tackle these failures. We'll ensure some backup mechanism and all. So commonly occurring failures are type 1, 2, 3, and 4. Okay. So we should recover from those failures. So for because all these failures can occur, then there should be some recovery mechanism that should be done in a system, database system. So systems must keep sufficient information to recover quickly from these failures. Okay. So disk failure or catastrophe have long recovery times because the hard disk is completely gone. Then there should be a backup disk or something like that. Then we have to uh, do all those backup kind of thing in order to recover the data. So this is a reference. Thank you.